Hello folks, so this is 2021 May June paper 42 and the question number is 9. This question is concerned with the chapter element induction and now in magnetic field. The first number A asks us state two situations in which a charged particle in a magnetic field does not experience a force. We know that a charged particle in magnetic field does experience force. It says two situations in which they don't experience. The first thing is if the charge is at rest. If the charge is at rest, then at that time it doesn't experience any force because it doesn't produce any current. So only when it produces current that there are some interactions giving force. So no current, no force. Next is if the angle between, if the direction of, so if the angle between direction of B and V are equal to 0. That is, if they are moving in same direction, at that time also there is no force. So the formula for force is F equal to BQV sine theta. So if theta is 0 degree, there is no force. Now number B, it says a loosely coiled metal spring here is suspended from a fixed point as shown in figure 9.1. Fixed point here, suspended here. Electrical connections are made to the ends of the spring by means of a flexible lead. So flexible lead here, connections here, source here, switch here. The length of the spring is measured before the switch is closed. So it is measured when it is open, and then again after the switch is closed. So after switch is closed, so length measured twice. One is before switching on and next is after switching on. Now when the switch is closed, a magnetic field is set up around each coil of the spring. So since it is a wire, definitely application of current will make it produce a magnetic field. So let me put it here. By reference to those magnetic fields experienced Y, there is a change in length of the spring. So when you switch it on, it says that the length of the spring will change. State whether the spring extends or contracts. So what happens here is, when I switch it on, current flow like this. So each part of this thing will extend its field lines. So the field lines would be somewhat like this, circle like this, circle like this, and the direction of current will be like this. So it flows here, it flows here, and it flows here. So first is each turn produces magnetic field, since each act as current carrying conductors. So now what happens is, now each neighboring turn, let us say each neighboring turn, so this and this will act like two conductors carrying current in same direction. So each neighboring turn act as two conductors carrying current in same direction. So they attract. So because of that, there will be attractive force there. Attractive force exists between them. So because of attractive force, so this turn attracts this turn, this attracts this turn, this attracts this turn. Similarly, this and this attract, this and this attract, this and this attract. So that causes length to decrease. That causes the whole length of the coil, this whole coil should decrease. So and for between them, so because of that, the length of the whole thing will decrease. So that's the reason for this. Now with the switch in B closed, so now the switch in B is closed here, a small mass on the free end of the spring is now made to oscillate vertically. So we just to oscillate it like this. We oscillate it. So it's not viewable in the screen. We oscillate it like this. Using the principles of electromagnetic induction to explain why small fluctuations in the current in the spring are found to occur. So it asks us why small fluctuations in the current is produced. So what happens here is when we oscillate it, the coils oscillation causes the coils to sweep or cut the field lines or flux lines. Let us say flux lines. So flux lines. So when it oscillate, causes the coils to sweep or cut the flux lines. So this will produce produces EMF in the coils. What happens is because of the speed here, when it oscillates, the speed changes. So during oscillation, speed varies. So this causes. So therefore, rate of sweeping or cutting also varies. So this causes change in the rate of flux change. So this causes change in the rate of flux change. So the flux does not change at constant rate, it changes at varied rate. So because of that, so therefore E equal to minus d phi by dt shows that. So since this changes, shows that E also varies. So this causes variation in E as well. So since this is varied, E also varies. So that's why it gives small fluctuations in the current. So this causes I also varies. So since E varied, I also varied.